ERA is a coal-fired power plant, which has 1320 megawatt capacity in total, while TJB Unit 1 and 2 of same capacity were constructed earlier and in operation now by another company. The Tuminous coal, which is used as a fuel, is transported by 70,000 T Panamax vessel from Kalimantan and is unloaded by two ship unloaders installed at the coal jetty. Such coal is transported by belt conveyor and stacked by destacker reclaimers in the coal yard, whose storage capacity is 660,000 T. Coal stored in the coal yard is forwarded to the coal silo through stacker reclaimer, conveyor and tripper. Also, it can be forwarded to the coal silo through conveyor route directly from the dock. Pulverizer is supplied the coal from the coal feeder and crushes powder in order to be burned at the boiler. Pulverized coal, which has been crushed from the pulverizer, goes into for coal supply pipes with preheated air. Pulverized coal will be burned after being input into the center of the boiler through the coal nozzle of the wind box. The firing system is the circular ultra-firing system. TJB Unit 3 and for power plant boiler is a drum type circular ultra-firing, low nitrogen oxides combustion system, which uses the variable pressure operation when in partial load with single-stage reheat, balanced draft, high-pressure turbine bypass system. This boiler produces 2,285.5 T of steam per hour on a maximum continuous evaporation 175.3 bar, pressure 541 degrees Celsius, steam by burning coal of 278.5 T per hour per unit. The boiler's heating surface layout should be in order: primary reheater tube, secondary superheater tube, tertiary superheater tube, secondary reheater tube, tertiary reheater tube, primary superheater tube, economizer to the direction of the exhaust gas flow. The turbine is located at the operating of the turbine building. The capacity of steam turbine of TJB Unit 3 in power plant is 708.3 megawatts. For casing, single reheat, bleed heating, impulse type. For flow exhaust, 3-cylinder tandem compound and condensing type. And as 3,000 revolutions per minute when rated low, high pressure, superheated vapor of 174.3 bar, 541 degrees Celsius will be supplied to the HP turbine by going through main stop valve and control valve. The steam which went through the box of the HP turbine rotates the rotor by expanding, after going through 14 horsepower stages towards the turbine end. The steam which arrived at the exit of the turbine goes into the reheater through cold reheat steam pipe as a 37.5 bar, 329 degrees Celsius steam condition. The steam which has been reheated at 39.1 bar, 541 degrees Celsius in the reheat goes through the reheater stop valve and the intercept valve by the hot reheat steam pipe into the IP turbine. Reheat steam passes the single crossover pipe by going into the center of the IP turbine after going through 8 IP stages. The first half of the steam inside the single crossover pipe is supplied to the low-pressure turbine A, and the other half to the low-pressure turbine B. Generator is directly connected to the turbine shaft and rotates at 3,000 revolutions per minute. It has 3-phase 50 Hz 22.8 kV 0.9 power factor. For 0.4 bars hydrogen pressure at 800 to megawatt rated capacity. The generator stator winding uses a water cooling system, which cools by passing the water inside the winding in order to cool down the heat produced during operation. Stator core and the rotor winding is cooled by using hydrogen heating. Hydrogen is cooled down to the proper temperature by the hydrogen cooling system, which heat exchanges by the cooling water from the inside going through the flowing cooler. The ventilation of the hydrogen is done by the axial flow fan, which is equipped to the rotor shaft. The generator is connected to the main circuit breaker and the generator transformer by the isolated phase bus. The electricity which is generated is boosted up to 525 kV at the 786 megavolt ampere generator transformer. GIS is connected with the generator transformer along the line which is buried underground. This is a gas-insulated switch gear, which sealed the extra high voltage circuit breaker, disconnecting switch and the bus and etc. inside the metal tank by using the SF6 gas as the insulation medium. To lines at the main transformer transmit to the Ungaran substation, and the other two lines transmit to the Japara substation after being transferred to 150 kilovolts at the interbus transformer. Condenser consists of one shell per unit and gathers the low-pressure turbine exhaust and various types of drain to the hot well after condensing through heat exchange by cold seawater. Condensed water gathered in hot well is pumped by condensate extraction pump and is sent to gland steam condenser. The condensed water condensed at the gland steam goes through number 1, number 2, number 3 low-pressure feed water heater, and letting its temperature rise, and goes into deaerator. The condensed water comes out of the upper tray of the deaerator and passes through steam so that air and other dissolved oxygen is removed. The feed water that is deoxygenized at the deaerator goes into feed water storage tank and gets pumped out from the boiler feed water pump, which is loaded with a booster pump. Then the feed water passes number 5, number 6, number 7 high-pressure feed water heater and gets preheated to about 290 degrees Celsius when rated low and is sent to the economizer of the boiler. Seawater is used as cooling water in order to drain the exhaust steam of the low-pressure turbine. For this purpose, the intake system is located at the north coast of the power plant. Seawater is sent to the condenser after being pumped to the decirculating water pump per unit when the waste is removed at the trash rack and the rotary screen installed at the intake. Provide 1,840 cubic meters per minute of seawater to the condenser by seawater supply pipe and underground to drain and cool down the low-pressure turbine steam. The cooling water which finished heat exchange at the condenser emits to the discharge channel along the discharge tunnel. The electrostatic precipitator, which has a 99.5% of collection efficiency, is installed in order for the dust during the process of the coal being burned not be exhausted at the end of the boiler in TJB coal-fired power plant. Remove the dust and the exhaust gas collecting by the electrostatic attractive force after making it to have electricity by using the corona discharge inside the electrostatic precipitator by making the exhaust gas of the boiler go through the electrostatic precipitator. The exhaust gas, which the dust has been removed, goes into the flue gas desulfurization system through ID fan and booster fan. Sulfur dioxide of the flue gas is removed by the wet-type flue gas desulfurization system when the exhaust gas of the pressured boiler by the booster fan goes through the absorption tower. Sulfur oxide of the exhaust gas and the limestone slurry, which is sprayed from the top of the absorption tower, react to each other so that the slurry absorbs the sulfur dioxide gas. Clean exhaust gas, which has been desulfurized, is discharged to the chimney and generates gypsum byproduct of the desulfurization procedure. The water used at the power plant is produced by desalination system using seawater and supplied to the needed facility. The wastewater from the power plant is discharged after being purified at the wastewater treatment system. The ash produced after the coal is combusted at the boiler is taken out by the recycling company after it is temporarily stored by ash storage silo. The steam turbine is a heat engine which uses steam as a working fluid. It expands the high-temperature, high-pressure steam which is produced from the boiler inside the nozzle. The thermal energy of the expanded is changed into speed energy. It changes the speed energy into mechanical energy by crashing to the rotary blade. The rotor is turned by the turning gear before startup. Cooling water from the discharge of the condensate extraction is provided in order to cool down the heat as the RPM of the rotor increases. Cooling water is provided by the spray pipe of LPA and LPB. The cooling water which is provided cools down the overheated LPA and LPBS turbine. It prevents the air going in low-pressure part of the turbine after startup, or excess steam of the turbine high-pressure part, leaking into the turbine room or bearing housing, contaminating the lubricating oil. It also provides GLAM steam to GLAM packing head number 1 and number 2 of the HP turbine, GLAM packing head number 3 and number 4 of the IP turbine, and GLAM packing head number 5, number 6, number 7, and number 8 of the LP turbine. The drain of the GLAM steam which goes through each GLAM packing head of HP turbine IP turbine. LP turbine is recovered by the condenser, is sent to the GLAM steam condenser after being drained. It secures enough steam flow at the superheater when the boiler start up or turbine trips. Also, in order to maintain the steam at a high quality, it bypasses the steam from HP bypass to radiator and LP bypass to condenser. high-quality, high-pressure superheat steam goes into the radiator after going through the main stop valve and control valve into the HP turbine and through 14 horsepower stages. At the end of the turbine, steam which has been reheated at the radiator goes into the LP turbine after going through the combined reheat valve and into the IP turbine and through 16 IP stages into crossover pipe. Steam which came into the LP turbine emits to the condenser after going through 24 LP stages. Bleed steam at the bottom of the turbine in order to increase the turbine efficiency. Bleeding steam is used as the feed water steam of number 1 and number to feed water heater. Number 3 feed water heater. The aerator. Number 5 feed water heater. Number 6 feed water heater. And number 7 feed water heater. The generator is a facility which converts mechanical energy generated from the steam turbine to electric energy. The features of the generator are rotating field, cylindrical rotor totally enclosed, rated capacity 800 to megavolt ampere 3000 revolution per minute, 228 kilovolts 50 hertz, 3-phase and synchronous generator. When the rotor is spinning by the steam turbine, the generator is provided excitation current from the static excitation system with thyristor rectifier. The current provided from the exciter flows through the brush and collector ring to the rotor coil by form a magnetic field. Stator coil interlinkaging with the magnetic flux provided by the rotor and forms electromotive force according to the electromagnetic induction law. By placing 3 winding groups at intervals of 120 degrees, 3-phase alternate current, which is 120 degrees of electric phase angle, is formed. For generator cooling, the stator winding adopts a cooling method using water, and the rotor winding and stator coil adopts the hydrogen as a cooling method. Circulation of hydrogen is done by the axial flow fan attached to the rotor shaft inside the machine. Also, heated hydrogen is cooled hydrogen cooling system to the proper temperature. The bearing lubricating device for high-speed revolution is installed, and the seal oil system of the stator's both ends is installed to prevent hydrogen gas from leaking.